This is my Module 4 Mastery assignment. For Topic 1, I did Riemann sums. Riemann sums are a method of approximating an integral using the sum of rectangular ones. Midpoint sums rely on the use of the middle height of each section of the function in its approximation. Trapezoidal sums rely on the use of the areas of trapezoids to approximate the integral. Left-hand sums rely on the use of the left-hand height of each section of the function in its approximation. Right-hand sums rely on the use of the right-hand height of each section of the function in its approximation. When a function is increasing, the left-hand sum underestimates and the right-hand sum overestimates. When the function is decreasing, the left-hand sum overestimates and the right-hand sum underestimates. When a function is concave up, the trapezoidal sum overestimates and the midpoint sum underestimates. When a function is concave down, the trapezoidal sum underestimates and the midpoint sum overestimates. The average between the left-hand sum and the right-hand sum is the same as the trapezoidal sum. The example is a rocket has a positive velocity after being launched upward from an initial height of 0 feet at the time t equals 0 seconds. The velocity of the rocket is recorded for selected values of t over the interval 0 t to 80 seconds as shown in the table. You must find the mid, LHS, RHS, and trap using 3 portions of equal length based on this chart. We are finding the sum from 10 to 70, which is the length of 60, so we must divide this by 3 to get the 3 equal sections of 20 seconds. We multiply 20 by the middle number, so we would go to 20, and that would be 22. Then we will go to 40, and that would be 35, and then we would go to 60, and that would be 44. We add up our values of 440, 700, and 880, and we get 2020. For the LHS, we use the same width of 20, but now we multiply by the left value. So we would do 20 by 14, then 20 by 29, and then 20 by 40, and add these together. This will give us an LHS of 1660 feet. For the RHS, we keep the width of 20, and now we multiply this by the right value. So we do 20 by 29, 20 by 40, and then 20 by 47, and then we add these together. Then we get that the RHS value is equal to 2320 feet. The trapezoidal sum is equal to the average of the RHS and the LHS. So we add these together and then divide by 2, so we get 1990 feet. Topic 2 is U substitution. U substitution is the process of integrating that reverses differentiation performed with the chain rule. Use U substitution when presented with an integrand that contains the product of a function and its derivative. Let u equals g of x, then differentiate both sides of u equals g of x, and we find that du equals g derivative x dx. Now substitute d and du into our original integrand. Substitute u equals g of x back into our original antiderivative. The example is the integral of 2x cosine x squared dx. We recognize that x squared is the inside function, and then this is therefore u, and then we differentiate this, and we find that du equals 2x dx. Now we substitute back into the original integrand and find the integral of cosine u du. We can now integrate this function by reversing trigonometric integration, and we find that the general antiderivative is sine u plus c. We can't leave our answer in terms of u, so we must complete substitution and replace u with x squared. So the general antiderivative of the integral of 2x cosine x squared dx is sine x squared plus c.